So the idea behind linear approximation is that whenever you have a complicated function, let's just say f of x here, and you want to evaluate it at any particular point, let's just say at x0 here. The idea behind linear approximation is that you differentiate this. That would then give you the ability to work out the gradient at this particular point. And once you know, and by the way, this point here will have coordinates x0, comma f of x0 here. Okay, so the coordinates at this point here will be given by this here. Well, the idea behind linear approximation is that if you have a complicated function here, you differentiate it. That will then give you the ability to be able to work out the gradient at this particular point. So you in a way have your gradient m here. So once you have a gradient that and the coordinates at a particular point, then you should be able to work out the equation of a straight line. And from our section on graphs, whenever you have a gradient which you can work out after differentiating this here, you can work out your m, and you know it crosses through a particular point, this and this here. Then you can come up with an equation for a straight line. And the idea behind linear approximation is that you can evaluate it around here by, well, rather than working with this complicated thing here, we would then work with this simple thing here. Okay, but the important thing here is that once you know the gradient, and you know the coordinates of one particular point, then you can come up with this. So before we plow on with linear approximation, let me just give you some quick revision. So hang on. So whenever from our section on graphs, this is your x, this is your y. Whenever you have a particular point and you know the gradient at that point, you can always come up with an equation for this straight line here. Okay, so quick revision from our section on graphs. So start out with your y equals mx plus c, and you know this is your x, this is your y. You would start out with your y equals mx plus c. You know the gradient is 4, so you would put 4 into here. That will then give you this. But the thing is, you don't know what c is. You still got to work out your c. So you would select one particular point here. This one here. This is your x. This is your y. So you would put your x in. Don't forget, we still need to know c here. So you would put this x into here. Okay, and then you would put this y into here, and then blah blah blah, work backwards to find out c. Once you've got your c, then you can put it back into your original thing here. Okay, so your equation here would be 4x minus 5. The point that I'm trying to make here is that whenever you know the gradient and you know one particular point, you can always come up with an equation for that straight line. So now, hang on, let's look at the general case now. Let's say you've got a function here, f of x here, and at one particular point at x0 here. So the coordinates here will be x0, okay, and the height here will be f of x0 here, and the gradient at this point here, will be you differentiating this thing here. So the gradient at this point here will be f prime of this thing here, evaluated at x0 here. So you would put it into, well, so the gradient here is given by this, and you know it passes through here and here. Okay, so once you've got this information here, you can come up with an equation of this straight line. So start out with y equals mx plus c. You know the gradient here. The gradient is this bit here. So let's put this into your m here. That will then give you this. Okay, but then you still need to know your c. So the normal routine is that you look at the point that you look at one particular point. So this is your x. This here is your y here. You would put this into your x here, okay, and then you would put this into your y here. That would then give you this, okay, and then so this at the moment, hang on, so that would then give you this. Hang on, we started out with this, y equals mx plus c. We know the gradient, so let's put that into here, and then it will give us this here. But then we need to know c. So to find out c, our normal routine is to look at a particular point. This is your x, this is your y. Put this into the y, put this into the x here. Okay, that will then give us this thing here. Remember, we want to find out the intercept here. So we would rearrange it. So take away this block from both sides here. That would then give you this. So C is given by this weird thing here. Okay. So now that we know C, we can put it back into here. Okay. So don't forget, our aim here is coming up with an equation for a straight line here. We got to this stage here. So now we know C, we can put it into that C here, giving us this thing here. So this whole thing here is our C. Okay. And then rearrange it. So well, we don't actually need the brackets here. So hang on, this here is our C here. This whole thing here becomes this. It's just basically us removing the brackets here. Okay, and then visualize it as one block, and then another block here, and another block here. Bear in mind that this is your x that moves around. This here is your fixed point, x0 here. This x, the one that moves around here, is this x here. Okay, is this x here? Well, anyway, hang on. So that will then give us this. So we are currently here at the moment. And then hang on, let me think. And then switch these two around. Switch this and this around. Okay, so that would then give us this. And then looking at this here, you've got this block, and take away this block here. But the thing is, look at this. Here you've got one block multiplying another block. Here you've got one block multiplying this block here. This is in common. This is in common. Factorize it out. That will then give you this. So factorize it out. So here you've got your x, and here you've got your x0 here. So that will then give you that will then give you the equation here. Y equals this thing here. So this here is our equation of our straight line here. So when given a gradient and one particular point here, the equation of that straight line is given by this here. Okay. Yeah. Just bear that in mind. The point I'm trying to make in this video is that whenever you know the gradient and you know one particular point, you can always come up with an equation for this straight line. And the equation for the straight line is given by this thing here. Okay? Yeah. Okay.